Hello students, this is the chapter uh, Ordinary Differential Equation of Higher Order with the topic Method of Variation of Parameter. The steps to solve the method of variation of parameter. Suppose we have given second order ordinary differential equation. This is the general form of the second order ordinary differential equation with the right hand side is q of x, that is the function of x. Second order, that is d square y by dx square plus a1 a2 is constant, a1 into dy by dx plus a2 with the dependent variable y and the independent variable is x. So uh, as we know, if our given equation is non-homogeneous, then first we have to find the complementary function, that is CF. Here the second order ordinary differential equations, so our CF is c1y1 plus c2y2. Now Wronskian, now we have to find this next step is Wronskian, that is W. So y1 in the denominator, y1 y2, y1 dash y2 dash. This is the formula for u and v. y2, y2, that is we get from the CF. Q is the right hand side of given differential equation. This is the Wronskian, which must not equal to 0. Similarly, for V, y1 we get from the CF. Q is the right hand side of the given differential equation. This is the Wronskian. Now, Pi is U, which we get from this equation, into y1 plus V into y2. Okay, so the general solution is CF plus Pi. So students, this is the basic step to solve the second order ordinary differential equation with the method of variation of parameter. First we have to find CF, then Wronskian, then UV, then substitute the value of UV in PI, and the finally general solution is CF plus PI. Now this method can also be extended to third order differential equation. For the third order differential equation, our CF is C1y1 plus C2y2 and C3y3. We get three constant for the third order differential equation. Then Wronskian, formula of Wronskian is y1 y2 y3 y1 dash y2 dash y3 dash y1 double dash y2 double dash y3 double dash, the denominator 3 by 3. Formula for find ux, we get y2 and y3 dash minus y3 y2 dash. From this, again q is the right hand side of the given equation and this one is Wronskian, which must not equal to 0. Formula for find Vx and formula for find Wx. Now Pi is Uy1 plus Vy2 plus Wy3, and finally general solution is Cf plus Pi. Students, here by mistake I forgot to write the C3 plus Y3. Here C1y1 plus C2y2 plus C3y3 and then this Pi. Okay, so let's start with the example. Our given differential equation is second order ordinary differential equation y double dash plus 9y equal to sec 3x. Okay, so we put this y double dash as d square. This capital D is the differential operator, that is d by dx. So here y double dash, so we can write as d square plus 9 into y equal to sec 3x. See, this is the auxiliary equation. For this is our non-homogeneous equation. For solving this, first we have to find the complementary function, and for solving complementary function, first we have to write our given differential equation in the auxiliary form, that is m square plus 9 equal to 0. The auxiliary form is the multiple of y and put m in the place of d, so m square plus 9 equal to 0. So the roots are m equal to plus or minus 3i, which is complex, and as per the rule of the complementary function, here our real part is 0, so e raised to 0x the bracket c1 cos 3x plus c2 sin 3x, but e raised to 0x is 1. So we can directly write c1 cos 3x plus c2 sin 3x. See, this is our complementary function. Now, if we compare with the general form of complementary function, that is c1 y1 plus c2 y2. So here y1 is cos 3x and y2 is sin 3x. Now time to find the Wronskian, that is here capital W, that is y1 y2 upon y1 dash y2 dash. Y1 is cos 3x, y2 is sin 3x. Now the derivative of cos 3x is minus 3 sin 3x. Here 3 cos 3x. By simplifying, we get 3 cos square x plus 3 sin square x equal to 3, which is not equal to 0. So formula for the pi u y1 plus v y2. Here y1 is cos 3x and y2 is sin 3x. Now we want to find the u and v. So formula for u is minus y2 q upon w dx. y2 is sin 3x. Q is the right hand side of the given equation, that is sec 3x whole by 3. By simplifying, we get sin upon sec is 1 upon cos, 1 upon cos. So sin upon cos, that is tan 3x, and integration of tan 3x is minus 1/3 log cos 3x. By simplifying, we get 1 by 9 log cos 3x. Now find v, that is y1q upon capital W. So that is cos 3x sec 3x upon 3. By simplifying, we get integration of dx, that is just x, so x by 3. Substitute this value in the equation of pi. So your pi is u y1 plus v y2. Your u is 1 by 9 log cos 3x. y1 is cos 3x plus v is x by 3 into y2, that is sin 3x. So general solution complementary function plus particular integral, that is pi. So this is our complementary function c1 cos 3x plus c2 sin 3x, and last two term is the particular integral. So this is our final answer of the given problem. Now let's check one more example. D square minus 3d plus 2 into y equal to e raised to x upon 1 plus e raised to x. See, students, please see carefully your right hand side. You cannot solve easily by the other method. Uh, you cannot use here any shortcut method. Okay, so this is the auxiliary equation, m square minus 3m plus 2 equal to 0. By getting factor, we get the root m equal to 1 and 2, which is real and distinct. So as per the rule of the complementary function, we can write c1 e raised to x plus c2 e raised to 2x. Here your y1 is a multiple of c1, that is e raised to x, and y2 is multiple of c2, that is e raised to 2x. Now find Wronskian. So capital W is the denominator of y1 y2 and y1 dash y2 dash. By substitute the value of y1 y2 y1 dash y2 dash, and by doing the simplification, we get the final Wronskian e raised to 3x, which is not equal to 0. So your pi is u y1 plus v y2, that is u e raised to x plus v e raised to 2x. Now time to find the value of u and v, and the formula for u is minus y2 q upon Wronskian into dx. See, your y2 is e raised to 2x, q is e raised to x, your Wronskian is q is e raised to x upon 1 plus e raised to x, and your Wronskian is e raised to 3x. So here e raised to 2x and e raised to x is e raised to 3x. Here e raised to 3x, so both cut. So your remaining term is 1 upon 1 plus e raised to x dx. See, multiply e raised to x, e raised to minus x, both the in numerator and in denominator. So e raised to 1 into e raised to minus x, that is e raised to minus x. 1 into e raised to minus x, so e raised to minus x. Here e raised to x into e raised to minus x, so e raised to 0, that is 1. So in denominator we get e raised to minus x plus 1, or we can write 1 plus e raised to minus x. Okay, so here the derivative of the denominator is in the numerator. So we can write the integration of this term is like log of denominator, that is log of 1 plus e raised to minus x. Okay, so now find v by substituting the value of y1q and Wronskian. Finally, after simplifying, we get here e raised to 2x and here e raised to 3x. So by simplifying, we get 1 upon e raised to x in the bracket 1 plus e raised to x. We cannot find easily the integration of this term. For that, we multiply e raised to minus x in numerator and in denominator. So here we get e raised to minus x upon 1 plus e raised to x. Again, we cannot easily find the integration of this term. So uh, again we multiply e raised to minus x in numerator and denominator. See, in this term here, we keep this e raised to x in the numerator. So just keep this e raised to x in the numerator. So this is the e raised to minus x. Now multiply e raised to minus x in numerator and denominator. Okay. So we get this term. Okay. Now your right hand side like this means split into this two term. By splitting in this two term, there is no change in the value, but it's very easy to find the integration. So integration of e raised to minus x dx and integration of e raised to minus x upon e raised to minus x plus 1. So by using this formula, integration of second term is log of 1 plus e raised to minus x, and the integration of e raised to minus x is minus e raised to minus x. So your pi is u into y1 plus v into y2. Again, by simplifying, we get final pi, and the general solution is complementary function plus particular integral by simplifying. Sorry, uh, this is complementary function CF, and this one is your particular integral. So this is your final answer for the given problem. Okay, students, let's move with one more example of order 3, that is dq plus d into y equal to cosec x. So mq plus m equal to 0. This is your auxiliary equation. If we get m common, that in the bracket m square plus 1 equal to 0. So m equal to 0 is real and m equal to plus or minus I, that is imaginary. So your CF is C1 e raised to 0x. E raised to 0x is 1. So just keep C1 plus or minus I, that is C2 cos x plus C3 sin x. Because your real part is 0 and e raised to 0 is 1. So just keep C2 cos x plus C3 sin x, as the power of your given differential equation is 3. So we get 3 constant in our complementary function C1, C2, C3, which is basic rule. So our y1 is multiple of c1 is 1, y2 is multiple of c2, that is cos x, and y3 is multiple of c3, that is sin x. Now find the Wronskian by the formula. By solving this determinant, we get final 1. Now substitute the value of y1, y2, y3 in this pi, that is uy1 plus vy2 and wy3. Now time to find the value of u, v and w, and the formula for u is this. Here we can find the y2, y3 dash, y3, y2 dash from the formula of Wronskian. Q is the right hand side of the given equation and the value of the Wronskian, that is capital W. Now your y2 is cos x, y3 dash is again cos x, y3 uh, this is y2 and this is y3. Your y2 cos x and y3 sin x. Y3 dash cos x, y2 dash minus sin x. Q is cosec x. So by simplifying this, we get cosec x, and integration of cosec x is log cosec x minus cot x. Similarly for Vx, y3 by putting the values of in the right hand side of Vx, and by simplifying we get just cot x minus cot x. Integration of cot x is log sin x. Similarly for Wx, by putting the value and by simplifying we get just integration of dx, that is just x. So substitute the value of u, v and w in equation 1, that is the equation for pi, and by substituting the value of u, v, w in equation 1 of pi, we get this final particular integral, that is pi, and the general solution is y into complementary function c1 c2 here c3 plus this particular integral. So this is the answer for the given problem. Dear students, this method is most IMP for the exam, for the GTU questions. So thank you so much, and feel free to any query contact me. Thank you.